In just over, 4 hours from now, China is set to launch its Shenzhou 21 mission to the Tiangong space station.
China just pulled off the fastest crewed space docking in its history, completing the entire approach to Tiangong in only 3.5 hours. The footage looked calm, almost quiet, as the capsule slid toward the station, but that calm hides something much more unsettling. Behind the scenes, engineers were dealing with cracked glass, drifting debris, and decisions that had to be made fast before a small problem turned into a disaster. In this video, we'll uncover how China managed this extreme precision, why this record matters, and what it reveals about the growing risks behind every space mission. Because while the docking looked perfect, the truth is that this mission came far closer to danger than anyone watching the video ever imagined, the fastest docking in China's history. The desert launch site shook as the Long March rocket blasted into the sky, leaving a bright trail of fire behind it. The force of the engines was so intense that even people far away could feel the ground tremble. It looked like a normal rocket launch, but something very unusual was about to happen. China wasn't just sending astronauts into space. It was about to complete the fastest docking in its entire space history. That raises a few simple but shocking questions. How did they do it in only 3.5 hours? Why does this achievement matter so much? And what hidden problems were happening behind the scenes while the world watched the perfect docking clip? On launch day, the atmosphere at the Desert Launch Center was tense and extremely focused. Dozens of engineers sat at their consoles, quietly watching their screens. Every piece of data mattered. The rocket stood in the sunlight, tall and white against the sand. When the countdown hit 0, the engines came alive with a deep roar, and the rocket slowly began rising before shooting upward at high speed. The timing of the launch had to be exact, down to the second, because the spacecraft had to enter orbit in the perfect position to catch up with China's Tiangong space station in record time. Reaching orbit is only the first part. The real challenge starts afterward. In space, you can't just fly straight to a destination. Everything is moving extremely fast, so a spacecraft has to match the space station's orbit before it can dock with it. A fast docking means the spacecraft gets into an orbit very close to the station's path right from the start. This reduces the number of loops, or phasing orbits, needed to catch up. Earlier Chinese missions sometimes took around 8 to 12 hours because they needed more time to adjust their position. Shenzhou 21 didn't need that. It was launched into an orbit so precisely aligned with Tiangong that it reached the station in just 1.5 laps around Earth. That alone shows a huge jump in skill. This speed isn't just about bragging rights. A shorter trip is better for the astronauts, who have to sit in a tight, cramped capsule with limited space to move around. It also means the spacecraft doesn't need to carry as much fuel, oxygen, or power for a long chase. Faster docking can even help during emergencies, because a crew could reach the station quickly if something dangerous were happening in orbit. Achieving this timeline means China's software, trajectory planning, and ground control teams have all reached a very advanced level. Inside the capsule were 3 astronauts who represented different strengths of China's space program. The commander was a veteran who had already lived on Tiangong before and understood the station well. The flight engineer was much younger, part of a new generation trained in both physical skills and deep technical systems. The third crew member was a payload specialist who came from a research background, showing that China wants scientists working directly in space instead of staying on the ground. As soon as Shenzhou 21 reached orbit, the chase began. The spacecraft fired its engines several times to adjust its height and speed with incredible accuracy. If even one burn had been a little off, the whole fast docking plan would have failed, and the mission would have needed extra orbits. But every maneuver went smoothly. As the spacecraft got closer to Tiangong, the onboard sensors, cameras, and radar systems all worked together to measure the station's exact position. The goal was to bring the spacecraft in slowly and carefully. The docking looked calm and serene on video. The spacecraft lined up with the station's docking port, moved forward at a very slow speed, and made contact. Engineers call this moment soft capture, which happens before stronger latches pull the two vehicles together. There were no sudden shakes or twists, but while the world saw a flawless 3.5-hour docking, there was a second story happening quietly behind the scenes. Space debris, surprise damage, and engineers scrambling to prepare another spacecraft as a backup. And if this is what happened during a mission that looked perfect on camera, what happens when something goes wrong, where no one is watching? How China got here. While most people were focused on the 3.5-hour docking, China quietly began running experiments that could change how humans live, work, and even reproduce beyond Earth. How did a station that started as a small test module become a place where researchers are studying life itself in microgravity? And what does it mean that some of these experiments may decide whether humans can ever raise families away from Earth? China's journey to this point began much earlier, back when its first space stations were simple, short-term modules designed mostly to test docking systems and life support. The earliest Tiangong modules, launched over a decade ago, gave China a chance to practice the basics: how to guide a spacecraft toward a target, how to transfer supplies, how to keep astronauts alive for more than a few days at a time, and how to power a station continuously as it orbited Earth. These early missions were small steps, but each one added a new piece to a larger plan. When the fully assembled Tiangong station was finally placed in orbit, it represented the first time China had a multi-module, permanently inhabited home in space. The early crewed missions focused on finishing construction, installing external equipment, and making sure the station's life support, oxygen recycling, and energy systems could run smoothly for months at a time. One of the most important changes came when China began overlapping its crews, which meant one group would still be on the station when the next crew arrived. Shenzhou 20 and Shenzhou 21 were part of this rotation, passing the responsibility for Tiangong from one team to the next without ever leaving the station empty. This type of overlap might seem small, but it marks a major milestone because it signals a shift from short visits to continuous human presence. The International Space Station has followed this model for many years, and China is now using the same system to ensure that Tiangong is always staffed, always running experiments, and always producing new data. Continuous presence matters because some research cannot be done in short bursts. It requires months of constant monitoring, weeks of setup, and a stable environment where nothing suddenly shuts down or goes offline. Inside Tiangong, the layout is built around science rather than spectacle. The modules contain experiment racks that can support biology, materials, science, chemistry, physics, and medical research. There are specialized areas for external payloads that can be mounted on the outside of the station, allowing instruments to measure cosmic rays, solar activity, or radiation levels. Tiangong is also equipped for spacewalks, known as EVAS, which enable astronauts to install new hardware, repair instruments, or reposition equipment. The robotic systems can move payloads around the exterior, which reduces risk to astronauts and expands what experiments can be done. All of this makes the station more than just a home in orbit. It is now functioning as a real laboratory where the goal is to produce scientific results, not simply to prove that China can send humans into space. One of the most recent and surprising experiments involves 4 mice, 2 male and 2 female, that are spending months aboard Tiangong in the first long-duration mammal study in the history of China's space program. The experiment is tracking their behavior, metabolism, and how their bodies adapt to microgravity over time. This may seem simple, but it is actually one of the most important questions for the future of human settlement beyond Earth. Can mammals safely reproduce in space? Will embryos develop normally in low gravity? Will organs, muscles, or bones change in ways that make life off-world difficult or impossible? These mice are helping scientists learn whether long-term life beyond Earth is possible, not just for astronauts, but for future families. Alongside these biological experiments, Tiangong is also being used to test how advanced technologies perform off-Earth. One of the most important examples involves lithium-ion batteries, which power everything from satellites to electric cars. In space, these batteries face very different conditions: extreme temperature swings, higher radiation, and constant charging and discharging cycles as the station moves in and out of sunlight. Researchers are studying how the batteries degrade, how their chemical layers break down over time, and whether they can be made more stable for missions that will one day operate far from Earth. There are also quiet debates happening around some of these experiments, especially the ones involving animals. Studying reproduction and biological development in space raises serious ethical questions. Some people worry about the stress placed on animals in microgravity, while others argue that we cannot responsibly send humans to live on the Moon or Mars without first understanding how life responds to those environments. Tiangong's evolution shows clearly that it is not meant to be a symbolic achievement or a national trophy. It functions as a bridge, allowing China to test systems that will eventually support longer missions to the Moon and, later on, possibly Mars. The station teaches engineers how humans behave during isolation, how equipment ages in space, how biology changes without gravity, and how materials respond to constant radiation. These lessons will inform everything from life support systems to medical care in future deep space missions. The station's purpose is to gather the knowledge China needs before committing to more ambitious goals. On the global stage, Tiangong gives China something that most countries do not have: a fully independent research platform in orbit. Other nations often rely on partnerships to access the International Space Station, but China has built its own path, with its own hardware, training systems, and scientific agenda. This allows the country to control its timeline and priorities without depending on outside cooperation. The result is a station that not only supports its own missions, but also places China in a unique position in the next phase of human exploration. Cracked windows, debris, and stranded astronauts. Most people only saw the smooth, flawless 3.5-hour docking that made headlines, but almost no one noticed the small but frightening discovery that happened around the same time: tiny cracks in the window of a returning spacecraft. They were found during the rotation between Shenzhou 20 and Shenzhou 21, and while they were small enough to miss at a glance, they carried terrifying implications. The most likely cause was a piece of high-speed space debris, or a micrometeoroid hitting the glass while the vehicle was in orbit, something so tiny it might have been impossible to see with the naked eye. A cracked window in space is not like a cracked window in a building or a car on Earth. In orbit, the pressure difference between the inside of a spacecraft and the vacuum outside creates intense stress on every part of the structure. Even a microscopic flaw can spread or deepen without warning. If those cracks grew, even slowly, the pressure inside the capsule could begin escaping, and there would be no air outside to replace it. That is why engineers treat even the smallest damage as a major emergency. Space agencies around the world, not just in China, have strict rules about crew safety because there is no margin for error. If something goes wrong in orbit, rescue is not immediate, backup is not guaranteed, and there is little room for improvisation. For that reason, mission planners always assume the worst when they see damage, even if the capsule appears stable in the moment. When the cracks were discovered, China's space agency had to make a fast and extremely important decision. They had to decide whether the Shenzhou 20 crew should risk using their damaged spacecraft for re-entry, or whether they should switch to another vehicle. The Shenzhou 21 spacecraft had just arrived and was in perfect condition, so mission controllers decided that the older crew would use Shenzhou 21 to return home. It was the safest option, but it came with a major consequence. The newly arrived Shenzhou 21 astronauts now had no dedicated return capsule of their own, at least not until another spacecraft could be launched to replace the one that had taken their predecessors back to Earth. This is where the word "stranded" began appearing in headlines, but it wasn't quite as dramatic as it sounded. The Shenzhou 21 crew was safe aboard Tiangong, with full life support, water, food, oxygen, and everything else they needed to continue their mission. They were not in immediate danger, and the station is designed to support long-duration crews without constant worry. The real issue was not survival, but logistics and psychology. Astronauts are always supposed to have a spacecraft docked as their lifeboat, the vehicle they would use if something unexpected happened on the station. Being in orbit without that guaranteed escape pod changes the mental landscape of a mission, even if the station is functioning normally. It is similar to living in a house without having a door that opens to the outside. Everything is fine, unless an emergency happens. China responded quickly by preparing to launch another spacecraft, commonly called Shenzhou 22, which would serve as the replacement return vehicle. It was essentially a lifeboat mission meant to restore the normal safety margin for the crew already aboard the station. Preparing a spacecraft on short notice is not simple. Every seal, bolt, circuit, and tank needs to be checked repeatedly. Launching a crewed-capable spacecraft is never done casually. Yet the decision to move forward with the replacement showed that China is building the ability to respond rapidly when hardware is damaged or compromised. In spaceflight, adaptability matters almost as much as technology, because unpredictable situations happen even in the most carefully planned missions. The real villain of this entire situation was the one almost no one ever sees: space debris. Low Earth orbit is becoming more crowded each year. Old rocket pieces, fragments of satellites, paint chips, bolts, metal shards, and even objects smaller than a pea travel around Earth at speeds faster than bullets. A tiny piece of debris might weigh almost nothing, but at orbital velocity, it can hit with the force of a serious explosion. This danger applies equally to every spacefaring nation. The United States, Russia, Europe, India, and private companies all face the same invisible threat. The International Space Station has had to dodge debris many times, and some astronauts have captured images of dents and scrapes caused by debris impacts. No country has found a perfect solution for cleaning up orbit, which means missions continue to face the risk of sudden, unpredictable collisions with objects too small to track. The incident around the Shenzhou rotation reveals something important about China's space program. On one hand, the country has reached a level of operational skill that allows for extremely fast docking, efficient crew rotations, and complex scientific work aboard a large modular station. These are signs of a mature program, one that is capable of carrying out missions reliably and with confidence. On the other hand, China is still dealing with the same hazards that every other nation must confront when operating in space. No amount of planning can prevent a random piece of debris from hitting a spacecraft. No amount of precision can guarantee that every vehicle returns home without issues. The rapid launch preparations for the replacement spacecraft show that even advanced programs must scramble when something unexpected happens. This contrast between the public image and the operational reality is part of what makes this story so compelling. On the surface, the world saw the 3.5-hour docking and assumed that everything was running perfectly. They saw the clips of astronauts entering Tiangong with smiles and waving to cameras. What they didn't see were the engineers running risk assessments, checking crack patterns, reviewing pressure tests, activating emergency protocols, and preparing a backup spacecraft on short notice. They didn't see the hours of meetings where specialists debated the safest possible choice for both crews. Spaceflight often looks calm to the outside world, but underneath that calm surface, it is full of decisions that must be made quickly, carefully, and with total attention to detail. These events make the story of Shenzhou 21 more human because they remind us that the astronauts aboard the station are not just symbols of national progress. They are people whose lives depend on the strength of the hardware around them and the judgment of the teams guiding them from the ground. Even the most advanced technologies cannot remove all risks from spaceflight. A small piece of debris can change everything in an instant. A tiny crack can force a major change of plans, and yet the mission continued, the crew remained safe, and China pushed forward with its work. Thanks for watching. If you enjoyed this, don't forget to like, comment, and subscribe. Click the next video for more exciting content.